Okay, this example is on the introduction to integral calculus. Now, integration is the opposite of differentiation. So in differentiation, you added one, or you took it down, you multiplied and you reduced the power by 1. Here you're actually going to do the opposite, where you're adding 1 to the power and you divide by the new power. So integrating the first part, it's going to be 3x cubed, because we add 1 to the power, divide by the new power, and then do the same for the next one. It's going to be 2x squared, add 1 to the power, divide by the new power, and then finally for a number on its own, you're adding 1 to the power, so it's just going to be 5x. You can feel free to write in the ones, but there's no need to do that, because anything divided by 1 is just itself. Simplifying this down a bit, you can just divide both by 3, so you've got x cubed plus 2x squared plus 5x, and that's it done. For the second one, same kind of idea, although first of all what we need to do here is multiply out our brackets. To multiply out our brackets quickly, we can square the first, so it's 4x squared, square the last, so it's plus 1, and then the first by the last by 2, so it's minus 4x in the middle, and then we'll do dx on that. Now, one thing I actually forgot about here in the first one, make sure if there's no values here in the integration part, you make sure you put a plus c at the end. Okay, it's what's called the constant of integration. And the next one we need to do, so we're going to differentiate this, so it's going to be 4x cubed over 3. Then we've got minus 4x squared over 2, and then finally we've got plus x plus c at the end. Now to simplify this one, there's very little we can simplify here, just the second term, so it's going to be minus 2x squared, and then plus x plus c. So this is my answer to the first question, and then this one here is my answer to the second question. I cannot simplify them any further. As we go through the chapter, we'll be given values for the integrals, and we'll be able to calculate the values at the end. Moving on to example 2. Example 2 is slightly harder. The one step you have to do first of all to simplify it down. So for part 1, we're going to actually factorize. So I'm going to take out x common, and you'll see that x divided by x goes in one time. So we're going to find the integral of x squared minus 4 dx. And then the integral of that, it's going to be x cubed over 3 minus 4x plus c. On to the second example, we need to simplify it first before we integrate it. So it's going to be x cubed. We're going to take this power up, so it becomes x to the power of minus 2. And then this one here, the square root of x is x to the power of a half. And then we will integrate that. So it's going to be x to the power of 4 over 4. You're going to add 1 to the power of the next one, so it becomes minus 1 over minus 1. And then the last one is going to be x to the power of 3 over 2 over 3 over 2 plus c at the end. Now it's up to yourself. You can simplify this if you like, but there's no need to, since as we go further in the chapter, you will be putting values in. Now if you wanted to simplify it, it would become x to the power of 4 over 4 minus 1 over x, and then this one here would become plus 2 over 3 square root of x cubed, and then plus c. But there's no need to do that if you don't want to. And then part 3, one thing I'd advise here at the very start is to multiply in your brackets. Now multiplying in your brackets for this one, x to the power of a half times by x to the power of 1 becomes x to the power of 3 over 2. So you're adding your powers together, and then this one here becomes plus 4x to the power of a half. And then we're going to integrate that one. So you're adding 1 to the power, so it becomes x to the power of 5 over 2. And then we have plus, or over 5 over 2. Then we have plus 4x to the power of 3 over 2, all over 3 over 2, and then plus c. Again, you can leave your answer like this, or if you want to simplify it, it'll become 2/5 square root of x to the power of 5 plus 8 over 3, the square root of x cubed plus c. Now moving on to the last example, a curve with this equation passes through the point 2, 0. If f dash x is equal to this here, you have to find the value of f of x. Okay, so the derivative is equal to this, so we have to go backwards, so we need to integrate this here. So we need to integrate 3x squared minus x to the power minus 2. So I'm just going to take this up. dx. So we will integrate it first, which is equal to 3x squared, 3x cubed over 3. Then the next one is minus x to the power minus 1 over minus 1, and then plus c. Now then we're going to simplify this down. It's x cubed plus x to the power minus 1, or we can actually even write it as 1 over x, and then plus c. And then for the next part, we know our two coordinates. We know when x is 2, y is 0. So we know when x is 2, so we're going to put in 2 for x. We know y is equal to 0, so we can put that equal to 0. So it's going to be 8 plus a half plus c is equal to 0, and we're going to try to solve for that. So c is equal to minus 8.5. And then the final step is to write down, so we need to find f of x. So we've found what c is equal to, so to find f of x, it's going to be equal to x cubed plus 1 over x minus 8.5. So that is my function f of x.